knowing the basic shapes of graphs can be really important in the future. So let's just take a look at what some basic graphs look like in the equations that generate them. So we're going to take a look at a lot of pictures here real quick. So let's see, if we have an equation that generically looks like this, where both the x's and y's are linear, the equation we get out of this is a line, right? Of course, depending on what A and B are, how it moves this line around and kind of thing. If we have an equation that looks something like this generically, ax squared plus bx plus c, so where one of the variables is linear and the other variable is quadratic, right? Quadratic meaning the highest power is 2. What shape you get out of this is a parabola. Now, a couple of things can really change the shape of this parabola depending on what A, B, and C are. This can move it left, right, up, down, flip it upside down. And if you were to switch the linear and quadratic variables, like here, let's say x was linear and y was quadratic, it actually make the parabola go left and right, but we generally don't take a look at those right now. Let's see, another shape generally kind of looks like this. If we have absolute value bx plus c plus d. Okay, now taking a look at this, both of our variables are linear. What I mean is they're both raised to the first power, but one of them is inside an absolute value. The shape you get out of that, you get a V shape. Now again, depending on what all these different letters in here, A, B, C, and D, this can move this up, down, left, right, flip it upside down. And if we were to switch the places of the x's and y's, where the y was inside the absolute value, it would turn it sideways. Let's see, let's take a look at another shape. Generically speaking, let's say that looks like this. Y equals a square root bx plus c plus d. Okay, again, both of our variables are linear. Well, not quite, it's a little wrong. Technically, this x isn't linear because it's inside the square root, but what I mean is the power on the x is 1, the power on the y is 1 that we can visually see, but the x is inside a square root. What you end up with is this shape. It's really a half a parabola. Now in this case, it's if our parabola looks like this, it's half of a parabola turned on its side. Again, if we were to switch the x's and y's, this would be turned the other way. We have a few more graphs that we need to take a look at. I'm probably going to have to start over here. Let's take a look at one that actually kind of has two pictures to it. If we have y equals ax cubed cubed plus bx squared plus cx plus d. All right, this is a cubic. Now, the reason I'm drawing two pictures for this is because the picture can look slightly different depending on the different values for A, B, C, and D. Now, this is generally the shape that we see if we graph like x cubed. This is the one we're kind of used to. But depending on what some of these other letters are, you can actually have a more exaggerated kind of hump here in the middle. So it can look something like that. Now, again, this shape can be shifted left, right, up, down, flipped upside down, depending on what all the lower letters are. All right, those are our generic basic shapes here. There may be a few more that the book gives you, so take a look to see what your textbook gives you, but knowing what the shapes are just by looking at the equation is going to be very helpful in the future. Make sure that you can do it.